Hello everyone. Today we're going to talk about section 3.4, Equations of Lines, part 1, because there are going to be a few parts to this. I'm pulling most of the information from here directly from the textbook, which will go into more detail than what I'm going into myself. So if you would like more direct instruction, please refer to the online textbook accessible through your portal. Alright, first off, so a refresher from previous sections. We've talked about the slope-intercept form, such as we have y equals mx plus b, where the slope and the y-intercept are clearly visible. We've talked about the point-slope form, where if you know the slope of a line and at least one point, xy, that line goes through, you can write it such that we have y minus y sub 1 equals the slope times x minus x sub 1, or y is equal to the slope times x minus x sub 1 plus the second y value. We've talked about the slope of the line, such that we can find m by looking at the rise, the difference in the y values, over the run, the difference in the x values. We need to know at least 2 points that are on that line to find that slope. We've talked about horizontal lines when we have a slope of 0, such that y is equal to some constant value, creating a horizontal line at y equals whatever that constant value is. And we've talked about the vertical line, x equals c. What happens when our slope is undefined? We have a vertical line at x equals whatever constant that might be. So let's look at some examples. Write an equation in slope-intercept form of a line with slope 3, a y-intercept of -2, then graph the line. So we have a slope of 3, so m is equal to 3, and a y-intercept of -2. So our b is equal to -2. Put this into y equals mx plus b form, so y equals mx plus b. That's going to give us y is equal to 3x minus 2. As far as graphing that goes, well, I can sketch it out because we don't have some graph paper here. Sketch that out. We're going to have an intercept at y equals -2. So down there-ish. It's probably going to also go through the point, let's see, up 3 over 1. So up 3 over 1, that's going to be there-ish, up 3 over 1, there-ish, there-ish, there-ish. So we're going to have a fairly steep line for this one. Example 2, looking at slope and a point on the line. Write an equation in a point-slope form of a line with slope of -3/4, such that it contains the point -2,5, and then graph the line. So let's start off with what we have. Our m is equal to -3/4. We have a point that we're going to go through. Our point is going to be -2, 5. So we're going to use our point slope equation such that, let's use a different color there, such that y minus y sub 1 is equal to mx minus x sub 1. Let's plug in what we know. Y minus that 5 is equal to the -3/4 times x plus that 2. Why that plus? Well, we have in our base equation negative, and we're subtracting a -2. When we plug this -2 into this x1, when we subtract a negative, that's the same as adding a positive, giving us our equation here. Now, if we wanted to, we could rewrite this as y is equal to -3/4 times x plus 2 plus 5 to get it in a more familiar form. Yeah, that's that. Graphing wise, we have it going through the point -2, 5. So it's say -2, 5-ish there. It's going down 3 units over 4 units. You're basically looking at a line like so. Given 2 points, write an equation of a line through each pair of points in a slope-intercept form. So we have the points 0, 3 and -2, -1. First things first, we need to find the slope. So we're going to use our slope equation. M is equal to our rise over run, or the difference in y values over the difference in x values. Plug in what we know. This is going to give us -1 minus 3 over -2 minus 0, which is going to be the same as -4 over -2, which simplifies down to 2. All right. So we have our slope, our m. We also know if we look at our points, 0, 3. This 0, 3 means x is 0, y is 3, which is also our y-intercept. So our y-intercept, our b value, is equal to 3. Plug this into our equation. That was y equals mx plus b, and that's going to give us y is equal to x plus 3. Next, horizontal lines. Write an equation of a line through -2, 6 and 5, 6 in a slope-intercept form. So first things first, let's take a look at our slope, verify that we will in fact have a 0 slope. So m is equal to our rise, y2 minus y sub 1, over our run, x sub 2 minus x sub 1. Plug in what we know. That's going to give us 6 minus 6 over 5 minus a -2. And while this will become a 7, it doesn't really matter to us because this here becomes a 0. And anything, a 0 divided by anything is going to be 0. So our slope here becomes 0. We have a horizontal line. Point slope form. Since we have a slope and we have a point, so point slope form, let's say y minus y sub 1 is equal to m x minus x sub 1. We know that our m value here is 0. So that 0 is going to go there. We'll distribute it into our equation here, but 0 times anything is still going to give us 0. So we're going to have, essentially, y is equal, or let's back up, y minus y sub 1 is equal to 0, which means that y is equal to whatever y sub 1 is. In this case, y sub 1 for us, that's going to be 6. So 6 is equal to our y. So we're going to have a horizontal line at y equals 6. Let's look at equations of parallel and perpendicular lines. Write an equation in a slope-intercept form for a line perpendicular to y equals negative 3x plus 2 and contains the point 4, 0. Well, in order to be perpendicular, we have to make sure that the product of our two slopes is going to be -1. So we have to look at the negative reciprocal. Well, the slope of our initial equation here, called slope 1, is equal to -3. The negative reciprocal, which we will call slope 2, we would take that -3, flip it to become -1/3. Then we want the negative of a negative, so that's going to be just 1/3. Now we need to figure out the last part, because we have a slope, we have our y equals our m, 1/3 x, we got to figure out that b. The way we're going to figure out b is we're going to use these values here to plug them in for the x and the y specifically. So rewriting this equation, we have 0 is equal to 1/3 times 4 plus b, which, if we simplify it down a little bit, 0 is equal to 4/3 plus b, or put it a different way, -4/3 is equal to b. So write an equation in slope-intercept form for a line perpendicular to y equals -3x plus 2 containing the point 4, 2. Well, that's going to be y is equal to 1/3 x minus 4/3. Note, folks, I'm using 4/3, but you could also use negative 1 1/3. But please don't use decimals, as decimals are not as accurate as fractions are going to be. In general, don't use decimals unless you're specifically told to use decimals. All right, let's take a look at a real-world problem here. One that some of us might be familiar with all too well, or you might become familiar with once you get to college. Financial literacy. Benito is trying to decide which tablet computer to buy. Tablet X costs $249, and an average cost of apps is $299. Tablet Y costs $499, and the average cost of apps is 99 cents. Which tablet offers him the better price? So those of you in Algebra 2, who were in Algebra 2 last year, you may recall these sorts of optimization problems. Let's take a look at what we know. With regard to tablet X, so tablet X, if we think about it in terms of the cost, the overall cost is going to be equal to the slope times the some amount of apps we're going to buy plus the base price of the computer. So with tablet X, the overall cost is going to be equal to the price per app, $2.99, times the amount of apps we're going to buy, plus the base price of tablet X, which is $249. Meanwhile, tablet Y, well, its cost is going to be equal to the app price there, $0.99, times the number of apps we're going to use, plus the original base price. So now we have two equations which we can then use to solve and graph to figure out which one is better if either, or which one's better in different circumstances. So I'm going to pause the video here to graph this out, and then I'll explain everything. And we're back. So here on the x-axis, we have essentially the number of apps that Benito might buy. And over here we have the total cost. And as you can see, with the cheaper laptop, as long as he keeps his number of apps under a certain amount, about 125 apps, it's better for him to get tablet X. But if he decides to buy more than 125 apps, then it's going to be cheaper for him to buy the more expensive tablet up front. Now, folks, personally, I don't know about you. I have less than 50 apps on my phone, so I would probably go with tablet X. It's cheaper for me overall, but for all we know, Benito likes to download 5 apps a week. If we want to take this a step further, we actually find what the specific value is because these two lines intersect. So what we would do is set this equation equal to this equation and solve for A, the number of apps. That would make these two prices equal, which would make these two prices intersect. But that's more enrichment stuff. Anyone who'd like me to work that out, I'm happy to work that out in Zoom chats or tutoring or questions, but I'm not going to have it as part of our assignments yet. Take care, folks. Feel free to ask if you have any questions. We'll continue this on Monday with part 2.